Scale factor. The objective function is the wasted space in the container and is discrete, depending on which items have been placed. In order to improve the sensibility of the cost function, intermediate levels can be generated by scaling one of the unplaced items, and attempting to insert the reduced version of the item into the layout. Hence, for each unplaced item, a scale factor between is applied, and the algorithm attempts to place the item. If it fits, the scaled area of the item is subtracted from the objective function. Scale factor was determined by a finite fixed depth binary search, restricted to the interval. Adaptive neighborhood. The proposed algorithm is shown in Figure 3. The main modification is shown in the inner loop, where the choice is to swap two items in the placement sequence, discrete parameters, or to modify the rotation or translation of an item, continuous parameter. The proposed algorithm. Different types of positive feedbacks are studied in this work. The main concept is that rejected solutions do not contribute to the progress of the optimization process. Therefore, the distribution of the step size for each individual continuous parameter is adapted in order to increase the number of accepted solutions. This is accomplished by the adoption of a feedback on the proposed algorithm. The next candidate is generated by the modification of a single parameter, adding to it a summation of random numbers with a uniform distribution. Varies the index of the modified parameter and choose its crystallization factor. The resulted modification follows a Bates distribution centered on 0 with amplitude half. Its standard deviation is given by 1/23c. For c equals 1, as all operations on parameters are performed in modulus 1, the modification is the equivalent of taking a completely new parameter uniformly distributed in the interval 0, 1. As ch increases, the expected amplitude of the modification decreases. When at a given iteration, the modification applied to a parameter leads to a rejected solution, the probability distribution, crystallization factor, for that specific parameter is modified in order to have its standard deviation reduced, resulting in lower modification amplitude. This is the negative feedback. When the modification leads to an accepted solution, the distribution, crystallization factor, for that parameter is modified to increase its standard deviation, resulting in larger modification amplitude. This is the positive feedback. Different positive feedbacks are studied in this work, see Table 1. As can be seen, the higher the crystallization factor for a given parameter, the smaller the modification this parameter will receive during the proposed algorithm. The parameter is said to be crystallized,